continental plates. So I have some of those right here. Right, so we've got, Eurasian plate. I've got the African plate. I have the North American plate. What? Oh, why do I have all these plates? What am I supposed to do with them? Okay. Alright, so this isn't at all what we're talking about today. But we are going to be talking about continental plates, and what those look like is different than what I was just showing you. Now, you have to imagine that this outer shell of the Earth, that solid portion, it is not all one solid piece. It is broken up into a bunch of pieces. Now, just like this orange, right, as you can see in this picture, if you imagine that the peel of the orange, that is the plates, right? They're all broken up, but if you put them all together, they cover the entirety of the orange. What we're going to be talking about today is how do these plates interact with each other? Now, we've talked about sudden earth events that go on. We talked about that last week, earthquakes, volcanoes, and they are occurring primarily because of the interactions of these plates. In your handout, in section D, we're going to be looking at 3 main ways that these plates can interact. Where these plates meet each other, if you look on this orange, right along here, this is what we call our boundary. As you'll see in the rest of this handout, you're going to be having a definition for the plates as well as the boundary, and the boundary is the edge of these plates. We can have 3 different kinds of boundaries, which you can see in your handout. You have 3 boxes, and we're going to name each one. Now, the first one we're going to talk about is our diverging boundary. So diverging, you gotta imagine if something is diverging, right, or it's being diverted, well, we're trying to get it away. So diverging is we're moving those plates away from each other. I have these 2 plates, they're going to move apart, and we're going to see more of the mantle underneath, which is the actual fruit of this orange. Let's start with our diverging boundary. Now here are our plates. We're going to label them as plates. Even though this is our lithosphere, we're going to label them as plates because we want to make sure that we emphasize, when we're talking about the movement of these plates, it's called plate tectonics. So here we have a plate, here's another plate. It's a diverging boundary, which means that the plates are moving away from each other. These arrows are showing the movement of these plates, and they're moving away from each other. We know that underneath here, right, this is our mantle, or our stenosphere. We know that there are convection currents. Now, for convection currents to move plates away from each other, then we'll have one convection current like this, and then the other convection current kind of going the opposite direction. So you can see how we have these convection currents that are rising up this way, and then moving outwards, and then cooling, coming back down. What happens is if we have this diverging boundary, where we have these plates which are moving apart from each other, this isn't happening very quickly. So we're not going to, there's not going to be a big hole in the earth. But what will happen is we know that there's all this magma underneath, right? This is all magma. Well, we know already, we talked about this last week, that it's going to want to rise at a weak point in the crust. And that can include between plates that are diverging. It will actually start to form, what do you think? If you said volcano, you are correct. We will end up with a volcano. Now, as this magma rises, obviously, once it gets to the surface, we call it lava, but it'll harden into this rock, and we end up with a volcano. The next boundary we're going to talk about is called our converging boundary. Now, if you imagine something is converging, right, it's converging on one point, it's all coming together. We have 2 plates that instead of diverting away from each other, they're doing the opposite, where they're coming towards each other. You have to imagine the Earth. All of the Earth is not all land, right? We know that there is a large portion of the Earth that is covered in water. So it means that when you're looking at a map of the Earth that shows all of the plates, some of those plates have water above them and some of them do not. So for example, you don't have to draw what I'm going to draw, but we can have a plate like this that has water above it. And we can also have a plate that is continental. Now we know that because it's continent, it has to be thicker. Because if it was the same thickness, all of the water would rush onto that land. And so here we have, in this case, a continental plate. And here we have what we call an oceanic plate. This is the parts of the crust that are the thinnest. We talked about this in week number 1. The parts of the crust where there's ocean above it, that's where it's going to be the thinnest. And so that's where we have these differences in oceanic and continental plates. That's very important because when we're talking about converging boundaries, we can have oceanic plates running into other oceanic plates. We can have continental plates running into other continental plates, or we can have an oceanic plate running into a continental plate. What we're going to draw is a continental plate converging with an oceanic plate. So here I have my oceanic plate. You can draw the water above it if you want. As I can show you in this orange, when I have two plates coming together, they're going to push on each other, and eventually one of them is going to slide over top of the other. In your textbook, they call that subduction, and that's one of the vocab words. We're going to talk about that. Subduction means it's being pushed underneath. So what happens is when I have a continental plate and an oceanic plate, one of them is going to get pushed underneath. Because the continental plate is so much thicker, that's going to push the oceanic plate underneath it. It's going to push the oceanic plate underneath. Now, as they push together, it's also going to cause some changes to occur in this continental plate, which is mountains. Now, we're going to have convection currents similar to the last one, except they're going in different ways. I'll make sure I label this as my asthenosphere. So, see how these convection currents, they're both pushing these plates to come towards each other, right? They're not going this way, we're going to push them away, they're pushing them towards each other. Now, we talked about when we have two plates and they're coming right together, and there's a breakage between them or where they're not connected, we call that a fault. Now, this whole process here, what's occurring right here, this is all called subduction. Now, let's make sure that we draw arrows to show the movement of these plates. Now, there's two features that we'll often see if it's a continental to oceanic converging boundary. One of them is these mountains, as we said. Now, what we'll also have is below the ocean, right here, we have what's called an oceanic trench. Now, this next bit you don't have to draw. I'm just going to show you if it was a continental plate running into a continental plate. So if I have two continental plates, as they run into each other, what will happen is we'll start to form mountain. Because they're squishing together, we're going to have mountain formation. Now, the last boundary that we're going to talk about is called a transform boundary. So here's one plate. Now, this is just one plate, so we need to draw our other one. So this is our transform boundary. Now, you may recognize this from week number 2 where we talked about earthquakes, because what we're seeing here is we have these two plates moving right past each other. Now, again, like we said, when there's this space in between, right, where they're not connected, this is called our fault. These plates are moving along that fault, going opposite directions. So they're moving back and forth along that fault, which can cause earthquakes. Now, that's everything for this lesson where we're talking about plate boundaries. Use your textbook as well as this video in order to write definitions for each of those boundaries, as well as the rest of the vocab as part of that section.